When running 24 volts direct current through multiconductor cables, for example, cables with 25 conductors, it is essential to understand the requirements for derating the current carrying capacity or ampacity of those conductors. The National Electrical Code, or NEC, provides guidelines to ensure electrical systems operate safely and efficiently. One key aspect is addressing heat buildup within cables, which can occur when multiple current-carrying conductors are bundled together. Table 310.16 of the NEC is commonly used to determine the allowable ampacity of conductors based on their size, insulation type, and ambient temperature. However, this table typically applies to alternating current, or AC, systems. For direct current, or DC systems, and particularly those operating at low voltages like 24 volts DC, the derating requirements can differ. The primary reason for derating conductors in multiconductor cables is to account for the increased heat generated when multiple conductors are carrying current simultaneously within the same cable bundle. This heat buildup can reduce the insulation's lifespan and potentially lead to insulation failure, short circuits, or even fire hazards. Derating factors are applied to the ampacity values listed in Table 310.16 to compensate for this effect. These factors reduce the allowable current a conductor can carry safely. The NEC provides specific derating factors based on the number of current-carrying conductors in a cable or conduit. For example, if a cable contains more than 3 current-carrying conductors, the ampacity of each conductor must be reduced according to a specific percentage outlined in the code. However, there are exceptions and considerations that apply to 24 volts DC systems. Generally, for low-voltage DC systems, such as those operating at 24 volts DC, the need for derating may be less critical compared to higher-voltage AC systems. This is because lower-voltage systems typically involve lower current levels for the same power requirements. Lower current levels result in less heat generation within the conductors. Additionally, the specific application and installation conditions play a significant role in determining whether derating is necessary. For instance, if the multiconductor cable is installed in a well-ventilated area or is not tightly bundled, the heat dissipation may be sufficient to mitigate the need for derating. Furthermore, the type of equipment being powered by the 24 volts DC system can influence the derating requirements. If the equipment draws a relatively constant and low current, the heat generated in the conductors will be minimal. However, if the equipment draws large inrush currents or operates with fluctuating loads, the heat generation will be more significant, and derating may be necessary. It is also crucial to consider the specific insulation type of the conductors in the multiconductor cable. Some insulation materials are designed to withstand higher temperatures than others. Conductors with higher temperature ratings can often handle higher current levels without requiring derating. The NEC provides information on the temperature ratings of various insulation types, allowing you to select appropriate conductors for your application. In some cases, the manufacturer of the multiconductor cable may provide specific recommendations for derating based on the cable's construction and intended use. These recommendations should be carefully considered and followed to ensure safe and reliable operation of the system. To determine whether derating is required for a 24 volts DC system using multiconductor cables, a thorough analysis of the following factors is necessary. Firstly, the number of current-carrying conductors in the cable. Secondly, the ambient temperature in the installation environment. Thirdly, the type of insulation used for the conductors. Fourthly, the load characteristics of the equipment being powered. And fifthly, any specific recommendations from the cable manufacturer. If, after considering these factors, it is determined that the heat generated within the cable is likely to exceed the insulation's temperature rating, derating should be applied to reduce the allowable current. In situations where the need for derating is unclear, it is always best to err on the side of caution and apply derating factors to ensure the safety and reliability of the electrical system. Consulting with a qualified electrical engineer or inspector can provide valuable guidance and help ensure compliance with all applicable codes and standards. While Table 310.16 is a valuable reference for determining conductor ampacity, it is essential to understand its limitations and applicability to specific situations. For 24 volts DC systems, A comprehensive evaluation of the factors mentioned above is necessary to determine whether derating is required. Remember, safety should always be the top priority when designing and installing electrical systems. Adhering to the NEC guidelines and consulting with qualified professionals can help ensure that your 24 volts DC system operates safely and reliably. In conclusion, the need to derate conductors in multiconductor cables carrying 24 volts DC depends on several factors, including the number of current carrying conductors, the ambient temperature, the insulation type, the load characteristics, and manufacturer recommendations. A thorough analysis of these factors is necessary to determine whether derating is required to prevent overheating and ensure the safety and reliability of the electrical system. While Table 310.16 provides guidance on conductor ampacity, it is essential to understand its limitations and applicability to specific DC systems. When in doubt, consult with a qualified electrical engineer or inspector to ensure compliance with all applicable codes and standards.